and thank you all for joining us this morning. At Intellia, we're building a full-spectrum genome editing company with the industry's broadest and deepest toolbox to fully realize the promise of CRISPR-based medicines for both in vivo and ex vivo applications. 2021 was a landmark year for Intellia, during which we shared the first clinical data offering proof of concept for our platform and showing it is possible to precisely edit a disease-causing gene within the body through a systemically delivered CRISPR-based therapy. We initiated 2 additional clinical programs, dosing the first patient with NTLA-2002 and screening AML patients for NTLA-5001's first-in-human study. We nominated 2 new development candidates leveraging our targeted insertion platform, NTLA-3001 for alpha-1 antitrypsin deficiency, and a program for hemophilia B led by our partner Regeneron. We also presented several noteworthy platform advancements, including preclinical proof of concept for in vivo editing of bone marrow, a novel allogeneic technology to engineer cells capable of evading immune attack, and a proprietary base editor. And finally, we launched a new company called Avencell in partnership with Cellex and Blackstone to develop allogeneic universal CAR T cell therapies. This collaboration is another example of our strategy to maximize the value of our platform and gain future product rights to innovative therapies. While we accomplished a tremendous amount in 2021, we are already building upon these achievements in 2022. More specifically, this year, we're focused on 3 core priorities. First, accelerating the clinical validation of our in vivo pipeline. On this front, we're looking forward to presenting additional clinical data from our lead candidate, NTLA-2001 for ATTR amyloidosis next week. And later this year, we plan to present initial clinical data from NTLA-2002 for the HAE program. Next, we are actively expanding our pipeline by advancing NTLA-5001, our first wholly owned ex vivo candidate to enter the clinic, along with the nomination of multiple new development candidates in both the in vivo and ex vivo settings, as well as through strategic business development opportunities. And finally, we're building on our scientific leadership by driving forward key platform innovation through expansion of our genome editing, delivery, and cell engineering capabilities. With robust execution against these objectives so far in 2022, Intellia is firing on all cylinders. Our phase 1 study of NTLA-2001 recently expanded to include an additional arm with cardiomyopathy patients continues to progress. We look forward to hosting a company-sponsored event next week, during which we plan to present additional interim data from patients with hereditary ATTR amyloidosis with polyneuropathy. The event will feature data from all 4 dose cohorts in Part 1, the single ascending dose portion. It will include safety and serum TTR reduction data, as well as an early look at durability across all cohorts. We expect these results to inform the dose selection for Part 2, and we remain on track to initiate the single-dose expansion cohort in the first quarter of this year. For NTLA-2002, we continue to dose patients in the dose escalation portion of the phase 1/2 study. Based on the insights gained from NTLA-2001, which are directly applicable to NTLA-2002, we believe we've increased the likelihood of success as we advance this program. Looking ahead, we anticipate presenting the first cut of interim data from this trial during the second half of this year. In addition to NTLA-2002, we are now advancing 2 wholly owned development candidates for the treatment of alpha-1 antitrypsin deficiency, or AATD. This includes NTLA-3001, a gene insertion candidate for AATD-associated lung disease, for which we expect to file an IND or equivalent application next year. And today, we're pleased to announce the nomination of NTLA-2003, a knockout candidate for the liver manifestation of AATD. NTLA-2003 is designed to inactivate the SERPIN-A1 gene responsible for the production of abnormal alpha-1 protein in the liver, with the aim of halting the progression of liver disease and eliminating the need for liver transplant. For AATD, our modular platform provides us the optionality for patient-tailored treatments relevant to the particular disease manifestation. Moving on to our ex vivo pipeline, for NTLA 5001, we've begun enrolling patients in the phase 1/2A study and expect to dose the first AML patient with our autologous TCR T-cell therapy in the coming weeks. Today, we are also excited to announce the nomination of our first allogeneic development candidate, NTLA 6001. NTLA 6001 is an allo CAR-T designed for the treatment of CD30 positive expressing hematologic cancers such as relapsed or refractory classical Hodgkin's lymphoma. It was developed using our proprietary allogeneic cell engineering platform. In preclinical studies, our allogeneic T cells were shielded from immune rejection by both host T cell and, critically important, host NK cell attack. This approach is distinct from others and is designed to ensure long-term persistence of the engineered cells. We are currently advancing this program towards IND-enabling activities and plan to present preclinical data leading to the development of NTLA 6001 at an upcoming scientific conference this year. In parallel, we continue to drive forward our platform innovation, maintaining our leadership position at the forefront of the genome editing revolution. Reflective of this strategy, we announced in February the acquisition of Rewrite Therapeutics, a private biotechnology company whose DNA writing technology may enable a range of additional editing strategies. The acquisition of Rewrite further expands our leading genome editing toolbox by adding complementary technologies to our existing CRISPR-Cas9 and base editing capabilities, thereby allowing us to employ the best tool for each therapeutic application. With the strength and breadth of our CRISPR-based platform, we recognize that our proprietary technologies can have expanded application when we strategically partner with others who possess complementary capabilities. This year, we've already completed 2 strategic collaborations, both of which extend the reach of our platform beyond our core areas of focus and provide us with valuable commercial product rights to future programs. In January, we announced a collaboration agreement with Kyverna Therapeutics to leverage our allogeneic platform to develop KYV-201, an allo-CD19 CAR-T cell investigational candidate for the treatment of select autoimmune diseases. This is a novel approach aimed at targeting CD19 for inflammatory diseases as compared to traditional oncology indications. Importantly, we have an option to lead U.S. commercialization for this candidate under a co-development and co-commercialization agreement. And just this month, we announced a collaboration agreement with ONK Therapeutics to develop CRISPR-edited NK cell therapies for the treatment of cancer. NK cells are specialized, naturally occurring immune cells that play a critical role in immune activation against abnormal cells, including cancer cells. The agreement grants ONK a non-exclusive license to our proprietary ex vivo genome editing platform for up to 5 NK cell therapies. Similar to the Kyverna transaction, we hold rights to global co-development and co-commercialization options, including lead U.S. commercialization rights for up to 2 engineered cell therapies derived from the collaboration. Finally, earlier this week, we announced a lease agreement to develop a 140,000 square foot facility in Waltham, Massachusetts to support the manufacturing of key components for our CRISPR-based medicines. This new facility will be GMP compliant and offer capacity and capabilities to deliver preclinical through commercial supply for our rapidly expanding pipeline. The ability to efficiently and reliably manufacture our products is crucial to ensuring commercial readiness and ultimately for our mission to bring transformational medicines to patients. Altogether, with these recent announcements, we've carried forward the strong momentum of the past year, positioning Intellia to advance the next wave of clinical candidates while ensuring we stay at the cutting edge for years to come. With that, I'll now hand over the call to Glenn, our CFO, who will provide an overview of our fourth quarter and full year 2021 financial results.
Thank you, John, and good morning, everyone. Intellia is in a strong financial position as we aggressively advance and expand our pipeline. Our cash equivalents, and marketable securities were $1.1 billion as of December 31, 2021, compared to $597.4 million as of December 31, 2020. The increase was mainly driven by net proceeds of $648.3 million from our July follow-on offering, $45.3 million of net proceeds from the company's ATM agreement, $43.1 million in proceeds from employee-based stock plans, and $6.3 million from Regeneron cost sharing. These increases were offset in part by cash used to fund operations of $254.7 million. Our collaboration revenue increased by $6.3 million to $12.9 million during the fourth quarter of 2021, compared to $6.6 million during the fourth quarter of 2020. This increase was driven by $5.8 million in revenue recorded in 2021 from our joint venture with Avencell. Our R&D expenses increased by $32.9 million to $71.2 million during the fourth quarter of 2021, compared to $38.2 million during the fourth quarter of 2020. This increase was mainly driven by the advancement of our lead programs and the expansion of the R&D organization to support these programs. Our G&A expenses increased by $11.3 million to $22.1 million during the fourth quarter of 2021, compared to $10.8 million during the fourth quarter of 2020. This increase was mainly related to employee-related expenses, including stock-based compensation of $3.8 million. Finally, we expect our current cash balance to fund our operating plans beyond the next 24 months, as Intellia is well positioned to drive long-term growth. With that, I will now turn the call back over to John for closing remarks.
Thank you, Glenn. We are already well on our way towards executing against our strategic priorities across all facets of the business. We're advancing a robust pipeline, including both wholly owned and partnered programs, now with 8 development candidates, 4 of which are in the clinic. We're delivering against our corporate objectives and rapidly expanding the reach of our platform to accelerate the impact on patients. We're expanding our manufacturing network by adding in-house GMP manufacturing capacity to support our continued growth. And we've continued to propel our own scientific leadership and innovation to support the next wave of clinical candidates. Despite all this progress, we still have much to accomplish later in the year. Before we open the call to questions, we understand many of you are interested in the upcoming Intellia 2001 investor event. Given our proximity to the data readout, we will not be addressing any questions regarding our progress with Intellia 2001 or the planned interim data on this call. We look forward to sharing additional data with you next week and kindly request that you refrain from using today's call to ask questions on this topic. With that, we'd be happy to answer any questions about the rest of our pipeline and platform. Operator?
We will now begin the question and answer session. To ask a question, you may press star then 1 on your touch-tone phone. If you are using a speakerphone, please pick up your handset before pressing the keys. To withdraw your question, please press star then 2. At this time, we will pause momentarily to assemble our roster. The first question comes from Joon Lee with Truist. Please go ahead.
Hi, thanks for taking our questions and for the updates, and looking forward to the data next week. On the other pipeline program, can you elaborate on the strategy for 2003 and 3001? I mean, why not combine these as a single therapeutic program? And also, how do you plan to screen patients for these 2 programs? And I have a quick follow-up after that.
Thanks, Joon. Good to hear from you. At this point, we view the programs as independent. But that doesn't mean that there's not a point where, they could come together in a single patient. Proceeding the way we're doing it, it gives us, we think,
maximal flexibility, and as I'm sure you know, there's different disease manifestations that may tip the balance more in favor of one intervention for a type of patient and the other intervention for another type of patient. So at this point, we like to keep it simple, and we think that that's in the best interest of advancing the programs most quickly. I'm not sure I understood your question about screening patients. If maybe you could elaborate on that a little bit for me.
Sure. Do alpha-1 antitrypsin deficient patients manifest lung and liver disease separately? Isn't it driven by the same mutation, such that they should both have both manifest? The single patient should manifest both. I didn't know that.
No, I understand. Yeah, I understand. So that's helpful. You're correct in that the underlying etiology for either manifestation is the same gene, and it's important to bear in mind. The nature of the problem, however, plays out differently in different organs. So in the case of liver, liver disease, and patients can certainly have liver disease without lung manifestations, it's a local problem where the aberrant protein doesn't get out of the liver appropriately and it causes local inflammation, whereas most of the pathology occurs, and this is typically later in life, in the lung, when that protein that didn't get out is needed to prevent the development of emphysema in the lung. In that case, what you want to do is focus on replacement therapy. So patients frequently, particularly later in life, will have primarily the pulmonary manifestations, and oftentimes early in life, a small proportion of patients with underlying gene problem will have primarily a liver manifestation. Can be a mixed phenotype as time goes on, but typically it's predominantly one or the other. And so in this case, we're able to tailor the therapy for the particular manifestation. But again, that does not mean in any way that we can't bring them together in the same patient. Remember that what we're doing is knocking out the particular disease-causing gene with 2003, and the insertion program targets a different gene for its expression, which is the albumin locus. And so you can have both of these interventions residing in the same patient, but they can get there at different times. So again, we think this keeps it simple for us, at least at the beginning here, and gives us a good chance to learn as we go and tailor therapy.
Got it. And a quick follow-up, you recently announced acquisition of Rewrite for $45 million, and it seems like based on the founders, they have a tool that allows them to find more tools. Is this something, what did you see there that attracted you to the deal? Is that something that would allow you to do, next generation things like combine 2003 and 3001 in a single step eventually? Thank you.
Yeah, thanks. Well, Rewrite is part of our overarching strategy. So when we say we want to be a full spectrum and consider ourselves a full spectrum genome editing company, that means really three legs to the stool, the in vivo programs in the clinic, the ex vivo programs in the clinic, but critically important is that third leg of having a platform which essentially is a toolbox of all kinds of different modalities. I think it's a mistake to think that any one particular genome editing approach is going to be definitive and address all particular targets that one might want to pursue. And so we spend a lot of time and invest a lot of effort in building a toolbox that has all kinds of different editing modalities. It's also true we spend a lot of time thinking about delivery modalities. So, that toolbox is full of things that we think is going to really open up opportunities beyond where we already are as we go forward. So in the case of Rewrite, there's interesting technology there that permits us to do a form of gene writing. There's the canonical CRISPR, which we know is so powerful, and we've been presenting data that we've generated with that. There's particular instances where one might want to use a base editor. We think that's ideally suited for multiplex knockouts in the ex vivo setting. And then there's gene writing, where one can introduce sequences of varying lengths, including sequences as short as a single nucleotide. That technology, I think, is immature at this time, but with some of the capabilities that we have and the insights that we've built over the years, we think that we'll be able to mature it and bring it forward to add to the sorts of genetic problems that we can address. And as we make progress on that, we will present data at the appropriate, scientific and medical forums, so you get a sense of where we are and where we think that tool is serving as well. But again, just view this as another one more implement that we have that let's just keep broadening our scope.
Thank you so much.
Sure.
The next question comes from Maury Raycroft with Jefferies. Please go ahead.
Hi, good morning, everyone, and thanks for taking my questions. Acknowledging that you're not commenting on the ATTR polyneuropathy today, can you elaborate on how many ATTR cardiomyopathy patients have been dosed at this point, and if we can expect an update this year from this cohort?
Good morning, Maury. I appreciate your persistence, but that falls into the broader rubric, let's say, of 2001, and we'll be happy to talk about a lot of that stuff when we come together on Monday, and we'll devote the session to talking about the 2001 program writ large. So hope to see you there.
Got it. We'll definitely be there. And I guess as another question for HAE, just wondering if you can talk a little bit more about what to expect for that update second half of this year. Could we expect to see data from all three dose cohorts?
I think it's premature to say how much data we'll have. The goal is to share some data in the second half of this year, and you should anticipate that we'll think about it very, very similarly to what we did with, last June with 2001. We apply the same principles of having information that's consistent, meaningful, interpretable, and that guides us. But we're making good progress, as we said in earlier remarks, moving that forward. And one of the things, as we said earlier, that we particularly like about that program is that, this modularity is playing out very much in our favor, we believe. Same lipid structure, same mRNA cargo, and essentially the same guide with the exception of about 20 nucleotides. So that's given us the ability to move a little further into the cohorts, the cohorts that we began 2001 with. And so we think we'll be in a really good position later this year to share information that we have that hopefully corroborates some of the findings that we had with 2001. So stay tuned.
Great. Okay. Thanks for taking my questions, and I look forward to the update next week.
Super.
The next question comes from Salveen Richter with Goldman Sachs. Please go ahead.
Hi, this is Tommy on for Salveen. Thank you for taking the question. I wanted to ask about business development in terms of your overall strategy and whether we should expect to see more deals in 22, and if so, what are you looking for in a partner? Thank you.
Yeah, thanks for that question. So we have a strategy, and you asked for a time frame, so let's leave the time frame out because what we're not going to be able to do is commit to any particular deal within any particular time frame. But I think based on what you've seen already, you should start to get some notion of how we think about our work here. So we are first absolutely laser focused on our pipeline and those programs that we guide to, that we control or have, our significant participation in. And that is very much foremost on our minds, and we will always remain focused on that. However, we find that some of the insights that we've gained from the work in our research area are more broadly applicable and go outside the realm of what we can or are able to immediately reduce to practice. And in those cases, we believe that if we can find complementary technology or more importantly, perhaps complementary biology, we love those partnerships because what that does is it gives us an opportunity to make products more competitive and ultimately serve patients better by combining, the insights of two groups as opposed to just one. What we try to do is maintain some significant participation in those products. And I think if you look at the deals we've done now since, the first one, which is Advancell last year, in every case, we've retained some significant commercial participation, and our partners like that, and we like that, and we think it's in everybody's best interest. So the idea is have essentially a parallel pipeline that does not consume substantial resources on our end, but leverages the insights and resources of others that are catalyzed by capabilities that we can complement their work with. And, when those opportunities arise, we will do them to the fullest extent possible. So, just one other element is if you step back and look at it, in addition to our own pipeline now, we have an NK cell partner, which we're really excited about. We have a universal CAR T effort, which we're really excited about. We've now moved into the autoimmune space, which we think is a wonderful opportunity. And we also have a position in the ophthalmology space. And that, I think when you step back and look at it, is a wonderful way of thinking about how genome editing can really be deployed in ways that are meaningful for patients. So watch us as we go, and just you should be confident that we're always looking and we're always thinking about possibilities.
The next question comes from Mani Foroohar with SVB Leerink. Please go ahead.
Hi, good morning, everyone. This is Greco on for Mani. Thanks for taking our questions. I have two questions for the AATD programs, and we can go one by one. But for the first question, I guess sort of going off of June's questions, was there something you observed in the NHP or other preclinical studies that you did with the combo approach that made you guys decide not to advance the combo program, but instead go with separate independent programs?
Thanks for the question. The answer to that is no. In fact, if you go back and look at that study that we presented, it really is two independent steps. And so what we did in those non-human primates was demonstrate exactly what we're doing in human beings, which is an insertion that produces high levels of the human protein, and that remains to be demonstrated, obviously, in the clinic, and in the case of the candidate now. But we showed that we could generate those high levels of protein production, inserting into the albumin gene. And I think that's an important point here. And then separately, and separated in time, we went and knocked out the offending SERPINA1 gene that was a key target for what would be causing the liver disease in humans with the mutation. And so, it's essentially identical to the way we're advancing it in humans. What we're not doing, though, is taking two investigational agents into a single patient at the same time, which we think is prudent, and we think it gives us the opportunity, again, to learn about the strengths and weaknesses, if any, of the various programs that we have before we think about bringing them together into a single patient. But we will always have that possibility down the road.
Got it. And I suspect each AATD program will have a different scientific and clinical risk profile coming from both the approach and the target patient population. Can you provide some insight and color around these risk profile differences between these programs?
Well, they are different in the sense that a knockout, 2003, is yet another example of the two knockout programs already in the clinic. And so, the principles that we're learning for 2001 and now 2002, we think are going to be immediately applicable to 2003. And so, just by virtue of having more experience in the clinic, we think that gives us just a clear focus on how that drug is likely to perform. The patient population is different, of course, and so we have to bear that in mind as we proceed. In the case of 3001, this is an insertion program. So you'll remember that these are hybrid programs where the insertion is both the combination of an LNP to target the gene where the insertion is going to take place, and then the template is provided in the form of AAV. That's new clinical territory for us, and we're doing the requisite preclinical work. Obviously, we presented data already in terms of non-human primates. We continue to build on that with our preclinical package for regulatory purposes. But, we just don't know as much in humans yet. And so I'd have to say that, there's just more uncertainty that comes with that program. But we will apply the same logic and principles that we applied with, the other programs before that. So hopefully our preclinical studies will serve us well.
Got it. That's all from me. I'll head back in the queue. Thank you.
The next question comes from Swapnil Medhekar with Piper Sandler. Please go ahead.
Good morning. Thank you for taking my questions. One question on 5001. So given that Venclexta is not applicable in unfit AML patients, and that might be the case with 5001, which may be limited to similar patient population due to conditioning regimen. Can you talk about the company's strategy to differentiate versus some of the competitors in that space, and how you could address a broader AML patient population?
Yes, Swapnil, I got everything I think at the last three quarters of your comment, but if you made a statement at the beginning that we couldn't quite hear about other agents, I think. If you could just restate that.
Sure, yeah. So just like when Venclexta it's approved and it's not applicable in unfit AML patients, and given that 5001 requires a conditioning regimen, so it might be limited in smaller number of patients. So like what's the strategy to go into a broader patient population? How could 5001 be differentiated in that space?
David, is that something you want to talk about? I mean, I think, Swapnil, just by broad strokes, we're in the early stages here where, the ongoing clinical study is collecting safety data and PK data and early response data in patients with low disease levels and higher disease levels. The thinking is, to the extent that we affect blast counts, and with that safety profile, that will determine the path where we go. And I don't know, David, if you want to add anything about conditioning regimens and how that might affect the trajectory of the program. I think it's the question here.
Thanks. This is David. I think that your concern is that unfit patients would not be able to receive the conditioning regimen. And remember that unfit patients are unable to receive intensive therapy, bone marrow transplant, et cetera. So this is a group of patients who is older, but it doesn't mean that they can't necessarily receive preconditioning of the type that's used for CAR-T or TCR therapies, and then receive TCRs, which themselves are expected to be more better tolerated than CAR-T therapies. So I think that we will be able to, some point, be treating patients who might otherwise be considered unfit for a bone marrow transplant.
Got it. Thank you. And then I have one question on 2001. I won't ask about the data expectations for next week, but there remains to be some concern regarding the cardiomyopathy part of the trial, given the BridgeBio failure. So are there any updated thoughts on your strategy in terms of patient stratification or endpoint selection to get an outcome that is more aligned or similar to tafamidis rather than BridgeBio?
We think about it a lot, and we'll be happy to talk about it on Monday.
Got it. Thank you for taking my questions.
The next question comes from Dae Gon Ha with Stifel. Please go ahead.
Great. Good morning. Thanks for taking our questions and congrats on all the progress. I'll also stick with non-2001. With regards to 2002 specifically, you mentioned in your press release there's a Quad AI meeting, so wondering what we can expect there given your announcement of interim cut in the second half. And as it pertains to the second half update, the press release also talks about biomarkers and preliminary proof of concept. So I think in our prior calls you've mentioned that it won't necessarily be reductions in attack frequency, but anything else that we should keep an eye out for? And also what kind of safety events should we kind of discount as disease-related versus drug-related? Thank you very much.
Yeah, thanks for the question. I mean, with respect to 2002, we're not guiding to any particular data sets. We will share information in the second half, and as we determine the appropriate place and time and all that, we'll give advance notice on that. What I would do is, as I said earlier, is look to what we presented in 2001 as a guide for the sort of information to expect for 2002. Attack rates are collected over some observation period, obviously in advance, and if you're looking for a therapeutic benefit, the longer observation period you have after that, the more you're able to speak to attack rates. We'll collect that information, but that is not the primary purpose of what we're doing in this first phase study. We're looking for the effects on the target protein, kallikrein, which is, the offending agent in this case. And the focus should be, the way you should be thinking about this, focus should be on how much of an effect we get on that protein knockdown. And then the way we do it is very similar to what we've done with the PTR program, extrapolate from the work of others in terms of what we anticipate is likely to be the clinical benefit and use that as our guide for thinking about the ultimate clinical utility. So we'll talk more about that as the year unfolds, but that's the way I would think about it for now.
And anything with regards to Quad AI meeting?
I don't think we've specifically talked about what we're going to present at which meeting yet. So again, as that comes into greater focus, but we'll provide additional information on our website once the meeting specifics are available, and that's how we'll talk about what we're going to present and exactly when. But at this point, we're not guiding to anything beyond that information. The time and place of the meeting, when the meeting permits us to talk about, we'll make it available on our website.
Great. See you guys on Monday. Thank you very much.
Thank you.
And a reminder to kindly limit yourself to one question. The next question comes from Luca Issi with RBC. Please go ahead.
Oh, great. Thanks so much. I'll try to behave and not ask a question about Monday, and maybe I'll limit to one question. But exciting data for the bone marrow tropic lipid nanoparticle last year. Wondering if you can comment on what's next for that program. Thank you.
It's an important target for us, one that we're very, very actively engaged in. We view that as a tissue that, after the liver, is one where LNPs will serve us well, and the research team is actively working to translate that work into the next level of species. And when we have more data to present, we'll do so at the appropriate scientific meeting.
Thanks so much.
Sure.
The next question comes from Mike King with H.C. Wainwright. Please go ahead.
Hey, thanks. Good morning, guys. I just wanted to ask you, in light of some of the regulatory and clinical challenges that have been seen recently with ex vivo modalities, just wondering how we should think about what differences Intellia will bring to the space, not only with respect to your proprietary programs, but also with respect to Vancell and Kyverna.
you have anything in mind, Mike, that you want us to speak to, or
well, there's been
a very general question
placed on. Yeah, there've been clinical holds placed on some programs. There have also been durability challenges with some others. So I guess that's kind of the framework of my question.
Yeah. So thanks. Remember that 5001 is up and running. We have an IND in the U.S. and the regulators have seen our package and the preclinical work that goes with it. And, despite what may have been the case with others, which I can't speak to, they've been satisfied with, all the preclinical work that we've done. And so we're actively enrolling patients. You go back to the overall approach that we've tried to take in this space. And this is how we think about the biology and using genome editing, et cetera. We've gone all the way back to the beginning in terms of asking very fundamental questions about how to get material into cells, for starters. In contrast with the preponderance of programs which use electroporation, we use lipid nanoparticles. We presented data that electroporation, no matter what your editing modality is, introduces genome breaks in translocations. And that is something that happens in a predictable fashion, but with unpredictable results. And, the work that we've done with lipid nanoparticles is just different from that. You essentially have levels of, translocations of breaks that are indistinguishable from cells that have never been, transduced in the first place. So it starts there. And then it relates to, the quality of the guides, the sequential nature of the work that we do as we introduce different genetic changes. And we carefully monitor that, measuring as we go the effect. And what we've presented is that, in our judgment, distinct from what others have seen, you have very, very low levels of off-target effects, A, and B, very low levels of, disturbed genetic architecture. So we think that puts us in a good position just, with the basics. Now, with respect to durability, for those allo programs where we've seen grafts lost in a matter of weeks, we don't find that a surprising outcome because it's well known that with reconstitution of the immune system, NK cells remove cells that lack class 1. And, we're seeing that in spades, I think, with other programs, that, in our judgment, falls short of what we're trying to do, where by taking a different approach, and we'll share more about that as the year goes on, with our allo program, that's not going to happen. We've presented data preclinically to show that, in fact, those cells, they're treated the way we do it, withstand and are not susceptible to NK-mediated attacks. So we think that augurs well for not just having the material ready when a patient presents, but also having persistence of the graft, which we think is really important for efficacy. And ultimately, we think that will address one of the fundamental problems in the space, which is the cost of goods. So altogether, we're hoping with the allo programs that we're moving forward, we'll have the clinical data that addresses those points and shows that our thinking does, in fact, play out the way we believe it will.
Okay. Appreciate the answer to the question.
Sure.
The next question comes from Steve Seedhouse with Raymond James. Please go ahead.
Hi there. This is Ryan Deschner on for Steve Seedhouse. For NTLA 5001, you noted that you've begun enrolling AML patients. Given this is an autologous therapy, could you talk about the vein-to-vein time, and do you anticipate problems with patients progressing while the cell therapy is being prepared?
Well, we will find the vein-to-vein time directly in our clinical programs as we proceed. But remember, we've shown in our preclinical work that we expect it to be around 3 weeks. That's, all aspects considered, and we benefit from the light effect of the LNPs, and we've shown that cells that have been transduced grow quickly and preserve the viability, and we think that translates into benefits in terms of the time between removing cells and returning them. So as we get our clinical data, we'll speak more directly to what we actually measure, but preclinically we would judge it to be around 3 weeks.
Wonderful. Thank you very much. Also, real quick, wondering if you had any sort of timeline for an update on potential progress or targeted indications for your base editor technology.
Today, we're not in a position to guide to that, but we like what we've got, and as I mentioned earlier, we think the base editor is ideally suited to multiplex knockouts in the ex vivo setting, and that's one of the things that we think about as we have more complex edits in the ex vivo space. So as programs advance, we'll talk a little bit more about that.
Excellent. Thank you very much.
The next question comes from Jay Olson with Oppenheimer. Please go ahead.
Oh, hey, congrats on the progress, and thanks for taking the question. Can you talk about the gating factors for filing the IND for 3001? And then related to that, can you also comment on the size of the commercial opportunity for 3001 and 2003?
So we break 3001 into a couple of parts. The first, remember, this is a hybrid application where we have the LNP coupled with the AAV. So the LNP, in many respects, is well advanced because it follows the work that we've done previously, and we know that program we generated data. So we're well down the road. In the case of 3001, a lot of this work has to do with the AAV and the template and some of the tox work that goes with that. And so I'm not going to give dates or anything like that, but that's the nature of the work that's underway.
Great. And can you please comment on the size of the commercial opportunity for 3001 and also 2003?
Well, we believe that there's substantial opportunity in the alpha-1 space generally, and we think it's measured well in excess of $1 billion, and depending on the reports you read, it's plural, billions applies. But at this point, we're not going to come up with a particular number. I think it's important to get more data in terms of how we think the actual drug is going to perform, and that's going to really determine where and how it plays, and we'll have a better line of sight to what is that ultimate value. But I would point out that the existing therapy for patients is inadequate. Patients progress and die on replacement therapy, which is essentially all that's available to them. And in the case of the liver setting, there's almost no effective therapy that's available for these patients currently. So we think that it's almost a wide open space at this point.
Great. Thanks for taking the questions.
Sure.
The next question comes from Yanan Zhu with Wells Fargo. Please go ahead.
Hi. Thanks for taking my questions. I have a question on the HAE program and a very, very brief question on the AML program. So on the phase 2 study of Intellia 2002, for the phase 2 portion of that study, I noted that you had designed 2 cohorts, 2 different dose levels, which is in contrast to your TTR program. Is there anything particular about this target in HAE that makes the dose selection maybe a little different, or is there some other reason? And the very brief question on AML is, are the two arms, the lower disease burden arm and the higher disease burden arm, are they going in parallel, or is one going into the clinic first? And could we expect any data from either arm this year? Thank you.
I'll do the second question, and David Lebel can address the logic of those two cohorts in the HAE program. But the short answer to the ML program is that they're progressing in parallel. And we're focused on enrolling the study now. We're not committing to a data disclosure. It's really going to be a function of the rate at which patient data accrues and what we have to look at. And back to what we've said on our other programs, we will apply the same sorts of principles that we've had about disclosing that data. And as soon as we can, we will. But it's really a function of getting the patients in the first place. So, David, do you want to just say a word about how you think about the different cohorts in the HAE program?
Yeah, hi, thanks. So we do think somewhat differently about dosing in the HAE program and the TTR program. So in the TTR program, there's good evidence getting to as low amounts of TTR as possible could be beneficial for patients. There's a good proportionality between that reduction and the clinical benefit that we'll see in patients. So, you'll see the data Monday where we're going with that. On the HAE program, there's more data that with lesser reductions, even just 80%, as we saw, an 80% reduction in prekallikrein, you get very major reductions in attacks on the aims of, upwards of 90% or higher. So we will be looking very careful at what dose we need to go forward with. The phase 2 does have that potential to have two different dose levels, though, of course, we could also go forward with a single dose level depending on what we find during the dose escalation portion.
Very helpful. Thank you.
The next question comes from Silvan Türkcan with JMP. Please go ahead.
Good morning, and thanks for taking my questions, and congrats with the progress. I just had a brief question about 5001. You kind of touched on, potential changes in persistency that you may have with your manufacturing. But could you tell us if you're exploring redosing in this trial initially, or if that's initially off the table and you will consider potential changes like consolidation dosing that we've seen in allo CAR-Ts, if you're even thinking about that? That would be great. Thank you.
David, what are your plans for redosing, if any, in the phase 1 trial for 5001?
Yeah, so we call it 5001 as an autologous program, so we really don't anticipate any issues with persistence in this program. So right now it is planned as just single dosing.
Thank you very much.
Okay, and I believe that there's time for one more questioner today. That will be Debjit Chattopadhyay with Guggenheim. Please go ahead.
Hi, this is Rai Forsteth on for Debjit. Two quick questions. What's the anticipated capacity utilization when the GMP facility comes online in 2024? And secondly, for 3001, what's the consequence of knocking into the albumin gene on tissue albumin levels and circulating albumin levels?
Well, we'll do the 3001 first. In the preclinical work, which we've done, we've had a de minimis effect on albumin. What we're not doing is knocking into every single albumin locus. That's something we've watched very, very carefully. And one of the virtues of the albumin locus is that it's probably the most highly expressed gene in the body, and so you get a lot of drive of the gene that you introduced there. So you can accomplish exactly what you need, at least in non-human primates, high levels of circulating protein that achieves the same levels of protein that humans produce while still preserving normal function of the albumin locus. So we think that that's an ideal place to drop in that particular insertion. With respect to the GMP facility, we're not in a position yet to talk about capacity and utilization down the road. I'll say this, we're really excited about the resource. It's a substantial facility that, it's 140,000 square feet. If you think about that and judge some of the other facilities that you see in this, our space, you'll realize that is a substantial commitment on our part. And we think it's going to put us in an excellent position to carry out not only what we're working on, but support some of those collaborations as appropriate as we go forward, and provide a really important resource to our increasing research efforts as well. So it's just something that we're all excited about, and as our work proceeds, I'm sure we'll be in a position to tell you a little bit more about our plans for that facility. So thanks for watching, and we appreciate that.
Thank you.
This concludes our question and answer session.